All right, 8.4 trigonometry part 2. Now we're talking about solving for angles. Everything we've done at this point is solving for sides or just writing the ratios, but now we're going to solve for angles. I said recall, the sine, cosine, or tangent of an angle gives us ratios of sides. Therefore, if we know the sides, we need to know an opposite function to determine the angle. So let me explain where this comes from. Let's say we have the cosine of some unknown angle x, and let's say that equals some ratio 4 over 5. Okay, what if we want to solve for x? Well, just like in algebra before, we need some opposite function to undo this cosine function. For example, let's say I had the square root of x equals 5. I need to undo this square root symbol. I do that by squaring both sides. These things are opposite functions. They cancel each other out. I get x equals 5 squared, which is 25. Okay, so we need an opposite function for cosine here, or for sine, or for tangent, depending on which one we're using. Well, you've probably seen this in your calculator. We have an opposite function of cosine. It's called arc cosine, and it looks like this in your calculator. Cosine to the negative 1. It's not actually cosine to the negative 1, but it looks like that. And so that's just the button we use in our calculator that determines, that's considered the arc cosine, or the opposite function. And so we can apply that to both of these, and we get the arc cosine and the cosine actually cancel each other out in a way so that you just get x equals the arc cosine of, in this case, 4/5. And then, only after I've solved for my angle, then I can plug this into my calculator. Okay. Well, since we already know what the sine is and the cosine is and the tangent is, we can actually just go ahead and write out the formula for each of these angles. See, the arc sine is going to convert ratios back to angles. Because if you remember, the sine function and the cosine function and tangent function, they converted an angle into a ratio for us. But now we're going to have these things convert the ratio back to an angle. Okay, so I said here, prove it. We could do that real quick. I'll do the sine one with you. So remember that the sine of angle A equals the opposite over the hypotenuse. And if I wanted to, I could undo the sine function with the arc sine function like I just talked about. And these things would cancel out. So I'd get that the angle A has to equal the arc sine of the opposite over the hypotenuse. And boom, we've just proved it. I'd like for you to go ahead and do that for the cosine and the tangent real quick, just so you could see kind of where that came from, and then we'll apply it to some problems. So pause the video, and then you can check and see if you did your work the same as me in just a second. Okay, so I went ahead and did this for the cosine. Again, we had the cosine A equals adjacent over hypotenuse. I did the arc cosine of both sides, which is also the inverse cosine. This is another word for it, but you'll probably see the arc cosine in a lot of your text or in books and stuff like that. So they cancel each other out, so you're left with just the angle equals the arc cosine of adjacent over hypotenuse. Same thing with the tangent. The tangent of A equals opposite over adjacent. Did the arc tangent to both sides, and you get that the angle A equals arc tangent of opposite over adjacent. Okay, now how can we apply that? Well, let's take a look at this problem here. It says find angle B. And just like before, I'm going to look at what two sides do I know. Before we were saying something like, hey, what side do I know, what side do I want to know? Well, now we actually know both sides. So I'm looking at angle B, and from the position of angle B, I have the opposite and I have the hypotenuse. So that tells me I'm going to be using the sine function. I don't know the angle, though. I don't know what angle B is, so I'm just going to write B equals the opposite over the hypotenuse. Well, the opposite here is 2, and the hypotenuse is 8. Now, that's how we used to write it out. But since I already know that the arc sine can convert ratios back, I could go ahead and take the arc sine of both sides like I did before. Get these to cancel. Or I could just start off by saying, hey, the angle has to equal the arc sine of the opposite over the hypotenuse. And now I'm actually ready for my calculator. You could reduce that too. But now we're ready to go to the calculator, and it's usually going to be a second or a shift command. So I hit second sine, and it gives me the arc sine. And 2 over 8 is the same thing as 1 over 4. Plug that in my calculator, and I get that angle B here equals 14.4, and I'm going to round to the nearest hundredth, so it'd be 4/8. Generally, we round to 2 decimal places unless we're asked to round somewhere different. All right, so we have angle B. Pretty straightforward. Once you guys give practice number 1 here a shot where you're trying to find angle A. I'll put the work up there in a little bit so you could come back and check your work, so just unpause it when you're ready to check your work. Okay, so I didn't start off writing the sine of the angle equals the ratio. I went straight for the arc cosine this time, because again I looked at my angle A, and I saw that from A we have the adjacent side and the hypotenuse, so that tells me it's going to be cosine. So I just went ahead and said the cosine -1, or the arc cosine of the adjacent and hypotenuse, has to equal my angle. So my angle equals arc cosine of 7 over 9. Now I'm ready to just plug that into my calculator, and I get 38.94. That must be the angle. Done. Let's go to the next page. All right, so now we get to apply this to some real life problems. This is where it gets real fun. First little vocabulary here. It says angles of elevation. This is the angle between the line of sight and the horizontal. Sorry, my handwriting's pretty bad here. Let's try it again. Horizontal ground. When an observer looks upward. So we got a little picture here to demonstrate it. Here's the horizontal ground. Here's the line of sight. So the angle of elevation is talking about this angle. All right, now, with that information, let's talk about this problem in example 2. It says the peak of Goose Bay Mountain is 400 meters higher than the end of a local airstrip. So here's the end of the local airstrip. The peak rises above a point 2,025 meters from the end of the airstrip. So that's this distance here. A plane takes off from the end of the runway in the direction of the mountain at an angle that is kept constant until the peak has been cleared. If the pilot wants to clear the mountain by 50 meters, what should the angle of elevation be? What should this angle of elevation be for the nearest tenth of a degree? Okay. So we're just trying to find this angle here, and we want this triangle, the big triangle here, not the small one. So we actually want this to be 450. This side is a total of 450 meters. And both this distance and our height are in the same unit, so we're ready to go. Okay, so we're looking for this angle. This angle, we have the opposite side of that angle, and we have the adjacent side, so that tells me we're going to use tangent. And so we could say that angle A must equal the arc tangent of the opposite, which is 450, over the adjacent, which is 2025. Bam, we're ready for a calculator. So we could reduce that 450 over 2025, but since we're going to calculator anyway, it really doesn't matter. So I'm going to press second tangent, 450 divided by 2025, and I get that angle A has to be 12 point, what do they want? Nearest tenth of a degree. I got 12.5 degrees. So our angle of elevation should be 12.5 degrees. That's it. Let's talk about an angle of depression. This is the angle between the line of sight again. When an observer looks downward and the horizontal. So this is the horizontal. So say you're up here in this lighthouse, you can look straight horizontal, or you could look down, and it's the angle between that horizontal and the line of sight. So this is an angle of depression. Here you have another angle, right? That if you were on this buoy here, this would be the horizontal ground, this would be your line of sight, this would be an angle of elevation. So angle of depression and angle of elevation are two different things, but like in this situation, since these are both parallel, these angles would be congruent. All right, let's talk about this problem then. It says the tailgate of a moving van is 3.5 feet above the ground. All right, already we're going to have to do some drawing, right? So here's a little tailgate. You can make your little moving van. It's obviously not to scale, but there's my moving van, there's my tailgate, and it is 3.5 feet above the ground. So here's my ground. And yeah, I know my van is hovering. Maybe I should have made the wheels a lot bigger here. There we go. Okay, 3.5 feet above the ground. A loading ramp that is 13.5 feet long is attached to the rear of the van. So we have a ramp that's 13.5 feet long. Find the angle of depression of the loading ramp to the nearest degree. Okay, so let's take a look at my picture here. The angle of depression, remember this is horizontal here. The angle of depression is going to be this tiny little angle here. I'm going to put a theta symbol saying that's our angle that we're looking for. So a couple things. One, this line is horizontal with this line, and so this angle is an alternate interior to this angle. So I can find this angle by finding this alternate interior angle. That may be a lot easier to do since we have a hypotenuse and we have an opposite of this angle. Or we can also just kind of extend this horizontal line, draw a line straight down, and then we also know that, hey, look, this distance 3.5 has to be the same as this distance of 3.5 feet. And then we can just find the actual angle that they're talking about. But it's going to be the same because, look, even from this angle, you have an opposite of 3.5 and a hypotenuse of 13.5. Or if you were to find this congruent angle, I'm going to mark these angles as congruent. This angle has an opposite of 3.5 feet and a hypotenuse of 13.5. Either way, we have the opposite and the hypotenuse, so we're going to use sine. And we're finding the angle, so we're going to use arc sine of the opposite, which we said is 3.5, and the hypotenuse, which we said is 13.5, is going to equal our angle. This little symbol, this little circle with a line through it, this is just a symbol that we call theta. It's just a variable that we use for angles. So if you haven't seen that yet, all that is just a variable for angles. It's kind of like an x or a y, but we just use it for angles. So now we're ready to go to the calculator. The arc sine 3.5 over 13.5 is about 15 degrees. So our angle here is 15 degrees. And yeah, that's rounded to the nearest degree, so we're good to go. All right, let's go to the last problem. This is always a fun type of problem. This is when we're dealing with two different triangles. So it says Olivia is in a lighthouse on a cliff. She observed two sailboats due east of the lighthouse. The angles of depression, so here's our horizontal, here's our angles of depression, to the two boats are 32 degrees and 57 degrees. Find the distance between the two sailboats to the nearest foot. Okay, they want this distance, all right? So we are looking for x. Here's the deal with this type of problem. You need to find this total distance. I'm going to call it t for total. Then you need to find this distance. Let's call it y. And you need to do the total distance t minus this distance y to find x. The reason being is x is not a part of a right triangle. If you look at it, the triangle here is not a right triangle, so we don't have enough information to solve for x. But we do have a right triangle here with side y. Let's make it a right triangle. And we do have a right triangle here with side t. And so we're going to use trig to find those two distances and then just do the difference to find x. Because if y plus x equals t, then x must equal t minus y. So we're going to keep that in mind. We'll come back to that later. So let's find t first. Well, t is a part of this big triangle. We need an angle in this triangle, and we do not have an angle in this triangle, but we do know that this is 32. And so we could do a few things. If this is a 90-degree angle, we could find this angle by doing 90 minus 32. Or we could do what we did earlier, and we could say, well, if this angle here is 32, then this angle here must also be 32 because it's alternate interior. So let's go ahead and do that. This is 32 degrees. And in the same way, for the next problem, if this is 57, then its alternate interior would be this angle here of 57. So I'm going to go ahead and write in a 57. Now, there is other ways you could have done this. You could have also said, hey, you know what, then this one must be 68. This angle here must be 68, and you could have used this as your reference angle. It doesn't really matter, but let's just use what we have here. So again, I'm trying to find t, and I'm going to go ahead and just color code this problem for you. So I'm going to go ahead and do green. I'm going to do t with green. Okay, so what do I know about t then? Well, I have this angle. I have this, I'm trying to find this adjacent side to the angle of 32 degrees, and I have this opposite side of 110 plus 85. And total, what would that be? We could put that in there. That would be total of 195 feet. So since I know the opposite and I'm trying to find the adjacent, that tells me I'm going to use tangent because of TOA. So let's go ahead and just type this out. The tangent of 32 degrees always equals my opposite. Again, my opposite of 32 is 195 over my adjacent of t. This is one of those problems where I have a t on the bottom, and so I'm going to just swap it with the tangent 32 over here, so I know that t equals 195 over tangent 32 degrees. Okay. I'm going to get a decimal for that, but I'm going to wait. I'm going to wait to get that decimal answer because, remember, at the end of the problem, I'm going to do t minus y. And so I don't want to write down some rounding thing, then write down something else rounded, and then get another answer that's even rounded. I want to be as exact as possible. So I'm going to plug this into my calculator at the very end. So I'm just going to leave this for now, and now let's go ahead and find y. I'm going to do y in red. So let's go ahead and draw this triangle. And that angle is 57 degrees. And it looks like I have the same two types of sides from angle 57. I know the opposite of 195, and I'm trying to find the adjacent, so that tells me I'm using tangent. So again, I'm going to say the tangent, but now of 57 degrees, equals the opposite of 195 over the adjacent of y. Okay, once again, I can swip the y and the tangent 57 so that I have y equals 195 over tangent 57. And now I'm ready to go ahead and plug in my calculator to find x, because remember x equals t minus y. So I know that x equals 195 over tangent 32 minus 195 over tangent 57. So I'm going to plug this all in my calculator at once. I'm going to do this part first, then hit the minus button, and then do this part and hit equals, and I think that I'll get the most exact answer that way. So 195 divided by tangent of 32 minus 195 divided by the tangent of 57. And I get that x must equal 185.4 feet, but remember they want it to the nearest foot, so my answer is just going to be that x equals 185. And that's in feet, sorry. Okay, fun problem, I know, a lot of work to it. Remember, the trick to these types of problems is to make two right triangles and then find the difference of these two distances to get the distance that you're really looking for. All right. It says, for your summary, I want you to define angle of elevation and depression in your own words. Go ahead and do that, and I'll see you guys on the next video.